Okay, welcome back to pre-calc or elements of calculus 2. We are going over some of the pretest problems. I am looking at problem number 7. So it says here, we have a tank holds 100 gallons of water containing 20 pounds of dissolved salt. A brine solution uh, flowing into the tank at 2 gallons per minute, while the solution flows out of the tank at the same rate. So in and out are the same thing. That's good. The brine solution entering the tank has a salt concentration of 2 pounds per pound rather. I didn't finish asking you the question. The question is going to be, could you come up with an equation that tells me the amount of salt in the tank at any time t after we have started the system? Okay, so let me go ahead and set this thing up. So this is a very standard kind of differential equation. So what we want to do is we want to say the change in the salt. We're going to say Q is the amount of salt in the tank. This is equal to, we're going to say the rate in times the concentration in, okay, minus the rate out times the concentration out. Okay, that's kind of much how you want to set this thing up. So let's go ahead and do a little bit of putting in some numbers here. So we're going to say dq is equal to the rate in. Well, it says that it's coming in at 2 gallons per minute, right? Going back over to the problem description, the water is flowing, the brine solution is flowing in at 2 gallons per minute. And what is the amount, the concentration is 2 pounds per gallon. So we're going to say we have 2 pounds per gallon going in. That's my concentration in. Some stuff is going to cancel. My units are going to cancel. So we're going to get 4 pounds per minute is going into the tank. Then we have to worry about the rate out. So we have 2 gallons per minute going out. Okay. And then we have to do the concentration. Well, here's the problem. We have some amount Q that is in the tank over 100, because that's how much started in the tank. But like there's some stuff coming in, and then we're going to be leaving some stuff going out. But I don't know how much is actually going to be in at one particular moment. Like if as soon as I start the system up, I don't actually know how much salt is in the tank anymore. At time zero, I know it's 20 pounds, 2 pounds, whatever it was. But right after that, I don't know how much salt is in there because some salt coming in, like some of this brine carrying salt came in. So I don't really know. Let's go ahead and clean this up. So instead of a dq, delta Q, I'm going to go ahead and shrink the delta down. So shrinking it down to a D. And we're going to say this is equal to 2 times 2 is 4 minus, and then 2 over 100. We're going to call that 1 over 50. Okay, so that is my differential equation that describes the system going on, right? We had 2 gallons per minute in, 2 pounds per gallon, 4 pounds per minute is coming in, minus some amount over 50 is leaving us. So let's go ahead and make this into the right form. So we have dq plus q over 50 is equal to 4. Or is equal to 4. All I did was push this to the other side. Realizing this is a first order linear differential equation. Okay, in order to solve that, we need to find an integrating factor. Okay, that's this magic thing that we're going to multiply both sides of the equation by, that's going to suddenly turn this thing into a form that we can tell what the differential is. We can tell we took a derivative, and then we're going to have the derivative in our hands when we get this done. And the way you do that is e to the integral of p dt. Okay, and p is whatever the thing is in front of the q. It's this piece right here. Okay, include the sign. Okay, so our integrating factor, p is equal to e to the integral of 1 over 50 dt. Well, that's not so bad. That's just e to the 1 over 50 t, or e to the t over 50. Let's go ahead and multiply that through. So we're going to say this is e to the t over 50 times, I'm going to write it as q tick. You could write it as dq, that's fine, plus, I'm going to say 1 over 50 e to the t over 50 q is equal to 4 times e to the t over 50. Just multiplied through everybody. Now, this side over here, this is what the integrating factor does to us. We're going to say, look, this is some q times e to the t over 50, okay, equals 4e to the t over 50. Now, what I would think you would want to do before we go on with this problem is take a little sidebar and say, look, if I took this derivative, okay, implicit differentiation, this is a product rule, so we're going to get derivative of the first times the second plus the first times the derivative of the second, right? The chain rule. And then let's compare. Do I have q tick e t over 50 plus q times e to the t over 50 times 1 over 50? I sure do. It's in a different order, but that's what we have. So this whole thing, once we have multiplied by the integrating factor, turns this thing into something that was a product rule. So we could say, this was the product rule of this product here, right here. This was a derivative from this product rule. So we're going to have q e to the t over 50 equals 4 e to the t over 50. And we know that this was a derivative. By fundamental theorem of calculus, we're going to go ahead and integrate both sides. And since we're taking the integral of a derivative, we're just going to get back what we started with. Okay, that's what fundamental calculus says we can do. And it equals. Now we're going to have to figure out, like, okay, we might have to do a u substitution here, but I'm going to trust that you're going to be able to follow that integration and say, okay, that's going to be e to the t over 50 times that 4. Don't forget, plus c, it was an indefinite integral. And then we're going to go ahead and solve for q. And we're going to say q is equal to 200. So what we're doing here is we're multiplying by e to the negative t over 50. When we go ahead and multiply by this term, those t to the e to the t over 50 and e to the negative t over 50, that goes away, plus c e to the negative t over 50. Okay, that's kind of what we're looking at as far as like a breather and saying, okay, what do we do now? Well, we still have to figure out what c is, okay? And here's where you go back to the problem and you say, what was the first sentence of the problem? Tank holds 100 gallons of water and contains 20 pounds of dissolved salt. Okay, so when t was equal to 0, we hadn't started the system yet. Q is equal to 20. Let's set that up. So we're going to say 20 equals 200 plus c e to the negative 0 over 50. Okay, e to the 0 over 50 is e to the 0. This is 1. So we're going to get 20 equals 200 plus c, and then we have a term here, but this term is just 1. So c is equal to 20 minus 200. This is 180 negative. So going back to our original problem here, we have q is equal to 200 minus 180 e to the negative t over 50. This is what I was looking for an answer. Had I actually written out the whole question? So that's what we actually have there. That's that's the amount of salt that is in the tank at any time t once we've started. Okay. A follow-up question might be, how much salt will be in the tank when the system is allowed to run for a very long time? Okay, so as t tends towards infinity, okay, how much salt will be in the tank? And we'll say, okay, well, Q is equal to 200 minus, and as t goes off to infinity, remember this graph is e to the negative x. That looks like this right here. Okay, t gets bigger and bigger and bigger. This is going to get to be a smaller and smaller and smaller amount. So this term is going to go to 0. So as t tends towards infinity, the amount that's going to be in the tank is going to be 200 pounds of salt. Makes sense, right? We have 2 pounds of salt per gallon coming in. There's 100 gallons in the tank. 2 times 100 is going to be 200 pounds of salt that are going to eventually be in the tank. So that's how you're supposed to solve that kind of a problem. On your exams, I'm kind of looking for Is your setup correct? Did you set up your DQ is equal to um, conc in rate in times concentration in minus rate out times concentration out? Did you set this up correctly? Did you set up your differential equation correctly? Did you set up your integrating factor correctly? Did you do that? Did you find your C? Did you answer all the questions that came after it? On the practice test, I failed to ask you any, but on the test, I will ask you. Come up with an equation for the amount of salt at any particular time. I might say, what happens after 4 hours? To type that in. What happens at t goes to infinity? What happens if it ran for 3 days? What would happen? So those are the little check places that I'm looking for is, do you set up the word problem correctly? Do you set up the system correctly did you set the system up? Okay. Did you solve the linear differential equation properly? Did you get a good iterating factor? Did you solve for the C at the end? Okay, there'll be parts A, B, and C here to kind of help guide you along the way because this wasn't really fair. Okay, but that's what I'm looking for how did you do this problem? I know that this is kind of a tough problem, so the one on your test is going to be very similar to the one you're seeing on the pretest, and that's how we're going to go ahead and do that. So if you can solve this problem, understand what all the pieces are doing, you're going to be able to solve the one on the pretest. Okay, so I'm going to leave you with that. Say, thank you for watching the video. Good luck studying for the test. Good luck on the test, and I will see you in the next video. Thank you.